Okay, ladies and gentlemen, what we're going to do here is we're going to continue with the 1.3 lesson plans. And what I want to do is I want to start with this example. Inside parens you have -2/5, and that quantity is raised to the -3rd power. Now, best way to approach this problem. This minus sign that you see in front of the 2/5, whenever you have a negative in front of a fraction, you have the choice. You can either put the minus sign with the numerator or with the denominator. And in general, I recommend to my students to put it with the numerator so that the denominator remains as a positive number. So, what I did here is notice in the next step, the -2 is what the numerator was, and I raised that to the -3rd power because that -3 goes with both the top. And notice what I have in the bottom. The 5 that used to be here is a positive 5. I don't need parens to indicate that. And it's raised to the -3rd power. Now look what happens. 5 to the -3rd from the denominator becomes 5 to the 3rd in the numerator. Remember, negative exponents take reciprocals, so they change positions from denominator to numerator and vice versa. The -3 exponent in the numerator is going to appear in the denominator as a positive 3. Notice that the -2 doesn't change. It's not the base that's affected with the move, it's the exponent. And then what we have now, when I finish the problem, 5 cubed is 125, -2 times -2 times -2, which is what the parens indicate we do, is -8. Positive divided by a negative becomes a negative, and we're left with the answer -125/8. All right, let's look at the next example. In the next example, which was basically 7a to the 3rd, b to the 7th, a to the -5th, multiplied by 2b to the 15th. You'll notice that I've drawn like 3 little sort of groupings or pairings, and what I'm basically trying to indicate here is this. The 7 and the 2 go together because they are basically just numbers. That's an arithmetic problem. The a to the 3rd and a to the -5th go together because they involve the variable a, and likewise the b to the 7th and the b to the 15th go together. So the way I approach the problem, 7 times 2 gives me 14. A to the 3rd times a to the -5th, a stays the same. When I'm multiplying, I add exponents, so I get 3 plus a -5, which becomes a -2 as the power of a. And on b, the base stays the same. 7 and the 15 get added because in multiplication, the base stays the same and exponents get added. 7 plus 15 becomes 22. I have 14, a to the -2nd, b to the 22nd. What has to happen here for our final answer, the a to the -2nd has to go to the denominator as a to the +2nd, because in general in math, in algebra, negative exponents are not considered proper form to be left in your final answer. All right, let's go down to the next example here. All right, we have a -8x to the -3rd, y z to the 5th in the numerator, and we have 2x to the -5th, y to the 4th, z squared in the denominator. Now again, what I try to do in this problem is I try to break things or put things together in pieces. So let's start. Of course, the minus sign remains in front of the problem. It's the opposite of. 8 divided by 2 is 4, so this is where I get the -4 in front, times. Now, on the x's, when we're dividing, laws of exponents tell us to subtract the exponents, whatever's in the numerator as the exponent there, minus what's in the denominator. So you'll notice that's how I get -3 minus a -5. On the y's, since it's also a division problem, notice that in the numerator there's an implied 1 Therefore, my new exponent on the y's will be 1 minus 4. And on the z, top minus bottom, top exponent minus bottom exponent would become 5 minus 2. So here's what we have. We have the negative 4 in front. On the x, we end up with a positive 2 when you do the arithmetic. Negative 3 minus a negative 5 is negative 3 plus 5, which is 2. On the y, 1 minus 4 is negative 3. That becomes our exponent. And of course, on the z, the exponent is 5 minus 2, which is 3. Our last and final step is very similar to what we did in the last problem. You cannot have y to the negative third in your final answer. Therefore, we take the reciprocal of it. The simplest way of doing that is moving it to the denominator and making the power positive. Thus, my final answer is the opposite of 4x squared z cubed over y to the third. Okay, let's look at this other example of an exponential type problem. We have 5x to the fourth, y to the negative second, inside parens, all being raised to the negative second power. Now, keep in mind that the 5 inside those parens is actually 5 to the first power. So you see there's an implied 1 there. Now here's what's going to happen. All right? Every time, and think about laws of exponents, when you have a power on the inside and you have a power on the outside, you leave the base alone and you multiply powers. So with 5 stays the same. 1 times negative 2 becomes negative 2. The x stays the same. The base is unchanged. 4, however, times negative 2 is negative 8. And on the y, negative 2 times negative 2 is a positive 4. Now, follow me on to the next step. Look what happens. 5 to the negative second appears in the denominator. We move it down as 5 to the second. X to the negative eighth moves to the denominator as x to the positive eighth. Y to the fourth stays where it is. And my final step, of course, is simply to square 5 to get 25, giving me the final answer of y to the fourth over 25x to the eighth. All right, this is as far as I'm going to go with this part of section 1.3, and there will be one more part to finish up these examples.